we have that the general binomial expansion, 1 plus x to the n, where n can be any real number, is 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 over 3 factorial x cubed, and so on. Therefore, in the case that we have 1 minus y to the minus 2, our x is actually equal to minus y, and our n is equal to minus 2. So this will equal 1 plus minus 2 lots of minus y plus minus 2 times minus 3 over 2, because 2 factorial is just 2, minus y squared, plus minus 2 minus 3 minus 4 over 3 factorial minus y cubed. And this can be simplified. Give me 1 plus 2y. Here, the double negative is going to cancel, and that 2 is going to cancel with that 2. So I'll get, and then the minus y all squared will be y squared, so I'll get plus 3y squared. And here the minus 2 times minus 3 will cancel directly with the 2 times 3. I'll get a negative from this triple minus y all cubed, and which will cancel with that minus 4. So I'm going to get this as my answer. And we've got the, y. The modulus of y must be less than 1. In part B, we have this series to look at. 1 plus 2x over x plus 3 plus such and such, x squared over x plus 3 all squared. Okay, I'm going to call this star. Now, what I can do is rewrite it as 1 plus 2 x over x plus 3. They're the same thing, I've just rewritten the fraction in a different way, plus 3 x squared over x plus 3 squared. Actually, it's this thing all squared. Let me rewrite that. Plus so on. And if you hadn't spotted it already, like just from here, we can see it now. If we compare it directly with the answer to A, it is exactly the same, but just with y replaced by x over x plus 3. So we can do that. Replace y by x over x plus 3 in A. And therefore, star is going to equal 1 minus x over x plus 3 all to the minus 2. And we've summed it. The only bit left to do is to rewrite it in a very specific way. 1 plus ax all to the n. So I'm going to put it over a common denominator. It's going to be x plus 3 minus x all over x plus 3. I want x on top, don't I? So I can flip it around with the reciprocal. It's going to be x plus 3 over 3 all squared. And we're nearly there. We just have to write it as 1 plus ax. So I can just swap these around. It's going to be 1 plus a third x squared. A is going to equal a third, and n is going to equal 2. Now remember it said, show that when it is convergent, and part C says find the set of values for x for which it is convergent. And remember that we had the modulus of y is less than 1, so we require that the modulus of x over x plus 3 is less than 1. Now, well, maybe there's more than two ways, but I'm going to go through two ways of which we could now deal with this. The way that I did it is I wrote it as an inequality. And I looked at two different cases. If x is greater than minus 3, then the bottom will be positive. And if we times through it, we'll get minus x minus 3 less than x plus 3. This bit is always true. And this bit will give me that 2x is greater than minus 3. So x is greater than minus 3 over 2. So if I think about this, I've got the x has to be greater than minus 3. So this is kind of my number line. Actually, yeah, it can't equal minus 3, can it? Because then we'd be divided by 0. So there's my number line. But now this here, I've got minus 3 over 2. I need x to be bigger than that. And so that one's going to win overall. That's going to be a condition that will work. I can't just have x equal to minus 2 because that won't be true, even if it satisfies this one. If x is then less than minus 3, then we would do the same thing, but when I times through, I will also have to flip the inequalities around. And this is never true. So we don't get any more solutions. It doesn't matter if there's possibilities over here. Yeah, this one can't be satisfied. And therefore, I'm just going to rewrite it again. Convergence for x greater than minus 3 over 2. A second possible way that you might have dealt with this would be to take the original modulus inequality, and you could write it as the modulus of x over the modulus of x plus 3 is less than 1, which means that the modulus of x is going to be less than the modulus of x plus 3. We can times through because we know that it's positive. And then you could draw a graph. Not like that. So you could draw y equals the modulus of x, which is y equals x here and y equals minus x here. And then y equals x plus 3 modulus is just essentially a translation by minus 3. I've drawn them both exactly the same color. I don't know why I did that. Let's change it. Better. So I can see that here is the point of intersection, and it would be when both are in the, oh sorry, it's when this one is still sort of positive, so it's going to be x plus 3, and then this one I'll have to take the negative, so it'll be minus x, from which I will get x equals minus 3 over 2. That'll be the point of intersection. Now, if I'm interested in where the modulus of x is less than the modulus of x plus 3, then it's going to be this region here, isn't it? And hence I will get that x has to be greater than minus 3 over 2. So just an alternative to solving this problem. Quite like this first way, if I'm honest, but the graph is good as well.